Lesson 2, Extrema on an interval. The max and min values of a function are called the extreme values of the function. The process used to find them is referred to as optimization. There will be times when we want to find the max and min for x on the entire domain, and so, that's going to have a method that we'll use. Other times, it might just be on a particular interval, and that is going to be a little bit different when we're finding it on an interval. In this lesson, we're going to learn how to use calculus to find the extrema instead of a calculator. So that is our mission. So first we're going to define absolute global extrema. If f is a function on an interval I, then y equals f of c is the number one absolute global maximum on I if and only if the function's value, so the y value at c, here's my y value at c, is greater than all the other y values on that interval. That's how I know I have a maximum at x equals c, and the value of that maximum is f of c. Okay, so the value of the maximum is that y value of the function if you have a maximum there. And then number two, the absolute or global minimum on I if and only if the function's value at c is smaller than any other y value on that interval. Okay, so again, it's happening at c, but the value of the minimum is f of c. Okay, it's really important that you understand if they're asking for the value, that you're giving them the y value of the function. If they're asking for where it's happening, you're giving them the x value of the function. So let's look at example number 1. The graph of y equals h of x is shown below. Determine the extrema of h of x on the interval from a to f. So we're not going to look at the endpoints here, okay? We're only going to look at everything in between. So I see that this in the neighborhood, and when we talk about the neighborhood, we're talking about, just any kind of, basically, this is like your neighborhood here. Any kind of neighborhood of that x value is the y there. So I'm going to follow this over. My y value is, h of b here. Almost wrote f. This is h of b, right? Because if I follow that y value over, that's where it is on the y-axis. This is considered in the neighborhood the smallest y value. So it is not the absolutely smallest, right? There's another one over here, but it's not really in this neighborhood. But so we're going to call this one a relative minimum, not an absolute. Okay, that one's going to be a relative minimum. The value of the minimum is h of b. And so you'd say h of b is the relative minimum of h of x. And you've also got a maximum at c, but is it the absolute? No. So this h of c here, this is going to be a relative maximum, because in the neighborhood, so if we just kind of picked a little neighborhood here around c and we looked at all the y values, it's going to be the highest y value. So that is considered a relative maximum. So we could say that h of C is the relative maximum. I'm saying it could be is A, right? Because the word relative, as long as it's in the neighborhood, any of these, in the neighborhood could be considered that. So in the neighborhood, H of D here is your minimum. So it could be considered a relative minimum, but when you're looking at it, you realize that more precisely, H of D is the absolute minimum on the interval from A to F. So you would say that H of D is the absolute minimum of H of X on AF, right? And then you have H of E. If I follow this across, here's my H of E. And so, again, in the neighborhood, it is the highest, but it's also the highest of all of them. So H of E is the absolute maximum of H of X on AF. Okay? So if we keep going here, relative or local extrema, y values on the graph of a function where the function changes from increasing to decreasing. Notice that if you're talking about or vice versa, but you're talking about going from increasing and then reaching a highest point and then going to decreasing. Here we're decreasing, reaching the lowest point, going to increasing then. Now, relative or local is going to be the one where I said it's in the neighborhood. But the absolute values can also be considered relative, but relative, not all relative, are absolute. It's almost like the square and the rectangle, where a square is a rectangle, but not all rectangles are squares. So we can say that, all maxes and mins can be considered relative, but not all maxes and mins can be considered absolute. Okay, there's only the highest or the lowest on a specified domain or on a closed interval. Okay. So definition of relative local extrema: if there is an open interval containing C on which f of C is a maximum, then f of C is called a relative maximum of f. If there is an open interval containing C on which f of C is a minimum, then f of C is called a relative minimum of f. And so here's some things that we want to just remind you of. When we say an open interval containing C, we mean that we can find some interval, AB, not including the endpoints, such that C lies between A and B. So that is, C will be contained somewhere inside the interval and will not be either of the endpoints. A relative extrema is slightly different than an absolute extrema. All that's necessary for a point to be a relative max or min is for that point to be the maximum or minimum in some interval of x's around x equals C. There can be smaller or larger values of the function at some other location, but relative to x equals C, f of C is smaller or larger than all of the other function values in the neighborhood of C. So that's what I was trying to show you on that last example. Example number 2, consider the graph of y equals g of x. Shown at the right, state the relative extrema of g of x. And so for this one, you have a relative maximum at x equals 2 right here. And it's a maximum in the neighborhood, but in the neighborhood of 2, but it's not the actual maximum of the entire function. So this is looking at it on the domain of the function. Okay, so this is one where we're finding the extrema on the domain of the function, because look, we've got the whole function here. It didn't talk about a closed interval. So on the domain of the function, we've got a relative maximum of 2 at x equals 2. We've got a relative minimum of, well, I'm seeing this right here. This minimum, it's the lowest point in the neighborhood, and the value of it is 0 at x equals 4. Remember, your maxes and mins are the y values. And now for part B, they wanted to know, what about the absolute? And I do see an absolute right here, absolute minimum. So we've got an absolute minimum value of -8 at x equals -3. Now, what about an absolute maximum? I look up here and I notice that this function is going to infinity on both sides. Therefore, this function does not have an absolute maximum. So we're going to say an absolute maximum does not exist. For g of x, because g of x is unbounded above. Basically, it's going to infinity on both sides. All right, example number 3. Consider the graph y equals f of x on the closed interval from 0 to 12. Find the relative extrema of f of x. All right, so it's on a closed interval, and there's something special about a closed interval. And we didn't talk about it on example number 1, but I do want to talk about it on this one. I'm going to point out the highest and lowest internally on this function, okay? So we've got x equals 2. There is a relative minimum. So let's write that, relative minimum value of, it looks like -2 at x equals 2. And then the next one I see, there is kind of a little, it goes from being a linear function to a downward facing parabola. But right here, you can't look at the neighborhood and say that this one is the lowest or the highest. Well, it would be lowest here, but you just can't look at that and say that. So therefore, we don't have anything at 5, okay? I just wanted to have you think about it. But now here at 7, we have a relative maximum. Remember, I said that this could be a relative maximum. Since this one is also the highest, it's going to also be absolute. But we can say it's relative. So we're going to say relative maximum value of 7 at x equals 7. And then we have another relative minimum value of 2 at x equals 10. And then considering the domain for f, what are the absolute extrema of the function? So if you're looking at your absolute max and absolute min on the interior of this function, you can see that your lowest is -2 and your highest is 7. And it's -2 at x equals 2 is your absolute minimum, and 7 at x equals 7 is your absolute maximum. So we have absolute minimum value of -2 at x equals 2, and we have an absolute maximum value of 7 at x equals 7.